In the previous slide, we have defined energy, and energy is the capacity to do work. Now, energy can be broadly classified into two types. You have the kinetic energy, which we dealt with last time, and this kinetic energy is the energy possessed due to the motion of an object. Every object that is in motion, like wind in motion, air in motion, a bullet in motion, a car in motion, possesses energy, and that is called kinetic energy. And the formula for kinetic energy is given as half mv square, where m is the mass of the body and v is the velocity. There is yet another form of energy, and that is potential energy. Now, potential energy is the energy possessed by an object due to its position or due to change in shape. So I said potential energy is due to change in shape or due to the position of an object. The potential energy due to change in shape is called elastic potential energy. And the one due to the change in position or due to its position is called gravitational potential energy. So energy, again, to repeat, energy is broadly classified into two: kinetic and we have potential. Kinetic is due to the motion of an object, and the potential is due to the change in shape or position of the object. The one due to shape is called elastic potential energy, and the one due to change in position is called gravitational potential energy. So here are some pictures of bodies having potential energy. So we just go over that. The energy of a body due to its position or change in shape is called potential energy. In the first picture, here we see a rock that is kept high up, and because this rock is high up, it possesses energy. So this would be gravitational potential energy because of position. In the second picture, we have a compressed spring, and a compressed spring can also do work. Now, how does the spring get its energy? It's because of its change in shape. The spring possesses its energy because of change of shape, and this such energy is called elastic potential energy. In this next picture, we can see the waterfall, and as this water falls, it falls with great energy. It can do a lot of work. Any stone kept in its path is pushed down, so it has got a capacity to do a lot of work. And why does it have this capacity to do a lot of work? Because it falls from a high position, so it possesses elastic potential energy. Not elastic, it will be gravitational. Why gravitational? Because it is from a high position. So this picture 3 is gravitational potential energy. Now, after the water falls into the river, now the river begins to flow. It begins to move. And if there's anything in its path, it pushes it along. It can do a lot of work. Flowing water can do a lot of work. So what kind of energy is possessed in flowing water? Now this would be kinetic energy, because it is due to the motion of the object. Now in the next picture here, in the fifth picture, we see an object, a brick, lying on the roof of a house. and this can definitely do work. If you drop it down, the potential energy gets converted into kinetic energy, and when it strikes the earth, it will do a lot of work. So this is gravitational potential energy. It has energy by the virtue of its position, hence gravitational potential energy. Now here we have a compressed spring, and this compressed spring first is unwound, and then work is done on it, and it is tightly wound. Now this tightly wound spring can do work because of its shape, because it's tightly wound, and this is elastic potential energy. This is how many of the winding toys work. We wind them, and as we wind them, we tighten the spring, and then the toy begins to work. So this is elastic potential energy. And last we have here the catapult. We put this as picture 6. Now we have picture 7, and you know this catapult, it can throw a stone at a long distance. But what must you do to the catapult? You must stretch it, you must pull it, and as you stretch and pull it, you change its shape, and hence it then gets energy to do work. It gets a capacity to do work. So the work here is due to change of shape, and because it is a change of shape, it is called elastic potential energy. So to repeat again, the energy of a body due to its position or change in shape is known as potential energy. Here we'll do a derivation for potential energy. For this let us consider an object of mass m that is kept high up at a certain height from the ground. The height is h. So here we suppose a body, say, of m kg, which is raised above the ground to a height h meter above the ground. Now in order to raise this object above, there is a downward force acting, and this downward force acting is the weight of this object, which is m into g. So work has to be done against this downward force. You have to do a work in the opposite direction. Force has to be applied equal to the weight of this object. Only then would you be able to lift this object. So we'll write here a force which is the weight of the object x downwards. Now in order to lift the object, a force equal to the weight has to be applied in the opposite direction. So to lift the object, a force has to be applied in the opposite direction. That is in the upward direction. Now the work done by this force, the work done will be always force into distance. Now we have seen that the force, in this case this force is the weight, and the weight of the object is mg. Into distance is the height through which it moves, that is h. Now the work done on this object in lifting it will be stored as its potential energy. So we need to write this: work done on the object is stored as its potential energy, is stored as potential energy of the object. Thus we can say now potential energy equal to mgh. Just to go over it again, so we know work done in lifting an object will always be force into distance. So when you lift an object, you have to do work against its weight, because its weight is acting downwards. Here the weight is acting downwards, and you have to apply a force upwards. Only then will you be able to lift the object. So the force in this case is weight of the object. Into distance. The distance in this case is the height through which you move the object, through which you lift the object. Now you know the weight is mg, that's the formula for weight, and height we know we write h. So the work done is mgh. This is the work done to lift an object. Now all this work done to lift an object is stored as potential energy of the object. So potential energy equal to mgh. If the acceleration due to gravity is 10 meter per second square, so I will write that as g 10 meter per second square, what will be the potential energy of the body of mass 1 kg? So m 1 kg, height 5 meter. So we need to find potential energy, and we know the formula for potential energy is mgh. So we have mass 1, the g is given as 10 and the h is given as 5. So this is 50 joule is the potential energy. So potential of energy of the body is 50 joule. A bag of wheat weighs 200 kg. So here mass, which we denote as m, is 200 kg. To what height? So height is question mark. Should it be raised so that the potential energy is 9,800 joules? So potential energy 9,800 joule. Now formula for potential energy, mgh, you put your values. The potential energy is 9800, mass 200. Here the g is to be taken as 9.8. The height you need to find. So height is 9800 over 200 into 9.8. So we now remove the decimal, 9800 into 10 to remove this decimal, over 200 into 98 equal to h. So you cancel 100. So the height will be 5 meters. So the answer you write, the bag of wheat should be raised to a height of 5 meters.